So we're going to try and determine the number of triangles that can be created given the information that we've been given in the question. So angle A is what kind of angle? It's acute. So let's draw ourselves a little acute triangle. If I'm dealing with the acute triangles, what are the side lengths I'm interested in comparing? Or what information am I interested in comparing, I suppose? All the acute triangles are in relation to the height. So somewhere in this calculation or decision that you're making, or in the work that you're going to do here, you need to figure out what the height of this triangle is. That's probably going to be your first step. Okay? And what I'll do is I'll show you how to get at that. But for right now, we're just going to draw the picture. Okay, you're drawing yourself a triangle. That's going to be angle C. And our question is, this is angle A, 40 degrees. Our question is, I think right out of the gate, how tall is the triangle? Given that side length B is going to be 19. And I don't really want to draw A on there yet because I don't know how long it is. Well, it's 12. Does that seem like a reasonable drawing? Maybe, maybe not. I don't know because the height, this is why it's ambiguous. I don't know how tall the height, like how tall the triangle is yet. Everyone good with that diagram? Kind of looks like the ones we did on the other page, but the only thing I need to figure out and where my inaccuracy is going to be is how tall this triangle is. If the triangle's not as tall, like let's say it goes from here to here, then that's actually going to touch. But the other piece that we got to think about is, does it touch in two spots or just one? But none of the questions that I'm asking you right now can be answered unless we figure out what the height of the triangle is. So that's kind of the first step, I think. Right? And if, let's just pretend for a sec, I only gave you that information. And this was the triangle that was provided to you in the question. This is like grade 10 question, right? That blue triangle. That's the information that's been provided to you in the question. Solve for H. What is H? Well, sine, if I'm standing here, this is opposite, this is hypotenuse, and so I'm going to use sine because I don't care about the adjacent side length. Everyone agree? And so if I were to go, sine of 40 has to equal opposite, in this case is H, over hypotenuse is 19. Then H is going to equal 19 sine 40. And if you do that calculation, you should see that H is going to be 12.2. Can anybody confirm that? 12.2? Yeah. Okay. So if I reference back to my little summary sheet on the other side, right? How many triangles am I going to get? Because now the question has also told you about side length A. And that side length A is 12 centimeters. So side length A is actually shorter than the height. So what does that mean? It means A is less than H. So what does that mean? That other side length never touches the bottom. Because if I swung it down here and drew another triangle, okay, if I took that side length A that was provided to me in the question, it's only going to go to there. Can we see that or no? Stop short of the bottom. So we don't get a triangle because A is less than H. Okay? Yeah. Do you want to try the next one? Okay, here, you try the next one. I'll sit stop. We'll just